Wireframing. Rachel, can you tell me what is user-centric design?
UCD.
Prioritizing the user experience in your design.
Spot on. And it was sort of it was like a buzzword that was a precursor to the buzzword that you're likely to hear now, which is having a customer first mentality. Think about the customer or think about the user as pretty much like your driving principle. Like everything else comes secondary to that. Like whatever it is that the business wants, cool. The business needs to define that in terms of what are we trying to create as far as human behavior. Okay, what is the high level impacts? What am I trying to achieve? Am I trying to get like more dollars donated? Am I trying to get more hours volunteered? Right? And then once you have that impact, you can derive an outcome, which is like what human behavior. So whatever team is like actually going to be doing this stuff, think of how do I make the number of hours volunteered go up? In order to do that, we need to get 10% more people, let's say for now, to click on this button to learn more. Now you've got an outcome that you can work towards. And that's when you maybe start thinking about features. Customer journey mapping. Is it something that one does sort of automatically when one makes wireframes? And it's so you think about like who is this user and what are they trying to do? Let's think of all features based on that human behavior. Like, let's think about like what's the first thing this user needs to be able to do? Okay, the sign up page. So we'll wireframe that. What's the next thing this user needs to be able to do after they sign up? Well, let's wireframe what that first time experience looks like. Instead of that first time experience being like the last thing and then spending like 2 weeks on the activity feed feature. Right? Because we've been, if you're not focused on the actual customer journey, it's really easy to get obsessed with things that are interesting to you.
Yeah, it seems to start with the solution before looking at the problem.
Yes, absolutely. If you don't know what you're going to be building, people tend to just start speaking in terms of these nouns that they define, they call the data structure. And while that can be a good starting point for building any cloud API, just like starting with something that's familiar is always going to be a good starting point for any user experience. Similarly, when you're creating an API, like a cloud API, an HTTP API, they're the user, and you're trying to create a familiar user experience by using URL like conventions that look familiar, right? So maybe you have like /users, and you send a post request to /users that creates a user. And then crud, you guys are familiar with what crud stands for? Create, read, update, delete. For a lot of things, that's how it works. Like if you have a database table, you can create a record in that table. You can read a set of existing records from that table. You can update some records in that table. You can destroy records in that table. REST stands for representational state transfer, but it just means CRUD for like the HTTP API. So like instead of a table, you're talking to some API. You're saying send a post request to /users, and that's how you create a record, right? You send a GET request to /users, and that's how you fetch some users. You send a put request or a patch request to /users/4, and you update users/4. Or user number 4. If you send a delete request to /users/4, you delete user number 4. So it seems real good in theory, but it's really, again, only good because it's familiar. Because deleting a user, like, first of all, who gets to do that? An admin? Like, why are you getting to delete a user? Or maybe it's deleting your own account, but then should it really be using, like, why do I need to know my ID to delete my own account? I'm already authenticating. So there starts to be some kind of like, it starts to fall apart even just structurally real quick when you start thinking about the user experience and what you're trying to create. But then it also just like, it doesn't fully capture the different possibilities. Like how do I do a search? I can do a GET request, sure. But it's not just as simple as going to /users. And you could even say that I'm going to use GraphQL or some like higher level protocol, such as the Blueprint protocol in Sails, right? Which is the same thing. I could try to use that to standardize how I do these CRUD operations. But realistically, like it's gonna vary on a case-by-case basis based on the feature I'm trying to build. And that's probably one of the biggest fallacies that you see with API design and interface design, as Rachel was pointing out. The same problem like bubbles all the way up to the surface, and it comes from inexperience and it's well-meaning, but it's never true. So Waterline, the database part of Sails is built on Waterline, which is using Node.js. Waterline talks to all these different databases via this adapter specification. And all of those adapters, they deal in terms of create, read, update, and destroy. And that's because Waterline is an ORM. It's an ORM, and you talk to it with You call like .create, you call .destroy. And when you need to do native queries, you still talk natively to the database. And you can get around the need to do native queries a lot of the time. But it's just, this works, like this CRUD abstraction works pretty well when you're talking about like a database, because the database is something that you address mostly in terms of these CRUD operations. However, once you get higher level out, it is not that simple. So I built blueprints in Sails with the thinking that like, okay, I want to make it so that you can write as little backend code as possible, right? The problem is there is backend logic that needs to exist, and whether you get around that by like layering on all these nested middleware things and policies, or you get around it by just writing custom backend code where you need it, it's getting dealt with one way or the other. This here is showing just a bazillion different npm packages. Like I used to think that the entire plugin system in Sails could be based around this create, read, update, and destroy fallacy. But I guess that just goes to show that like I knew what I was doing to some degree at that point. Like I built the framework, I built a lot of apps, but I still had this idea in my head that somehow create, read, update, and destroy or delete, that was like that was it. That somehow that was like going to be my guiding principle for how I would build things, instead of the guiding principle being the user. And kind of, I guess the point I'm trying to make is that the guiding principle should always be the user. It doesn't matter if you're building a plugin system. It doesn't matter if you're building an API. It doesn't matter if you're building a user experience. It doesn't matter if you're building an internal tool or an internal process for your employees to use. What matters is the person, the human behavior of the person that is participating in that process or in that UI. Okay, so a noun-centric ontology is great for building databases and integrations with databases, but it never works for 100% of any app. Imagine searching the store. You need to pass through a query of some kind that has some meaning, right? And imagine, but the reality is that, okay, but what does that really mean? Maybe it's like I want to search the name, I want to search the description of the product. So do we use CRUD? Because half the time we don't actually know what we're supposed to be building. And that's the real problem. So like, it's real easy to be like, well, I know how to design that. I know, create, read, update, destroy. I know how to design that API. I'll just make the models, do the data model first. It's going to be solid. It's going to be great. And like the thing is, every time you do that, it's because you didn't actually know what the product was supposed to be. From what I've seen, anytime when you start with the data model, the resulting product tends to be like all of the thinking ends up being around the nouns. It ends up being like, oh, okay, well we have these products, and then this is like okay, so we can list all the accounts, and like everybody's thinking becomes poisoned with this like noun disease. So then, okay, in much in the same way, it's not just this is not just kind of at the database layer. There's the API layer above that, and then there's kind of like your user interfaces above that. But this even goes up to the API. Like, so a lot of people will say, okay, well maybe we'll design the API first before we design the internals, before we design the implementation. And this is good. This is right. That's exactly what you need to be doing. Because that means that you're thinking about the user. API means application programming interface. Thus, the user is the programmer, right? The person integrating with the API. So that is good, right? It's good to think about the user first. But it all comes down. It's easier to think like, yeah, let's be API centric. Let's care about let's not just say that the programming interface is meaningless. Fuck it. Like, let's make it nice, let's be API centric, but let's just think about the user first every time. And specifically, you can also think of the UI first, and that's why we're so big on like wireframes and even just building the front end first when possible. At this point, luckily, that's permeated our industry. I think it's becoming more common to see that. But that said, you'll still see a lot of people that will go and they'll build the backend first, and then the UI hasn't been fully decided yet. And then it's like, cool, why the hell would you anchor yourself to this invention, this twisted invention of your mind that was built without even fully understanding what the product was supposed to be, presumably in the effort of pipelining the work or getting started early, or more likely what no one wants to admit, that it's easier to design the API first because you can just be like, oh yeah, create products, yeah, okay, products.
Got all this work done.
Right, it feels productive, it feels good. I've done it. It feels good, but it's wrong. It doesn't do anything. We need to flip things upside down, and we need to start thinking about design. Not writing documentation, not fixing code, not manually testing code, not deploying code, not discovering bugs, not redeploying code, not remembering how the code works, not discovering how the automated tests now, not updating the automated tests. None of that. We need to mainly be focused on design, and then all of that other shit that we do is there to make the design come to life. So we think of the user interface design. That's like, that's what you see on the screen. That's HTML and CSS. We think of the interaction design. That's how the DOM events and other, if you're in the DOM or wherever you are, the events, they get wired up. Cross fingers, your development starts. You've done this interaction design. You've done the user interface design. And then you're like, wait a second, I forgot to mention that we have to add this feature to the product. Can I see a preview? So that doesn't oftentimes work. And then the traditional development process, let's say circa 2005. 1, we design a data model. 2, we implement custom server code. And then 3, we start implementing custom UI code, which is, you guys were aware, we just talked about, that's like totally backwards, right? Because now you're designing this data model without having even thought about what you're creating. Like you're just like, it's like saying like, I want to start a business, so I'm gonna go file cabinet shopping for like 2 weeks. And then I'm gonna like permanently stain my understanding and my team's understanding of the business by making everyone think in terms of these file cabinets that have nothing to do with our goals, right? And then what happens is you're like, what the fuck is this? You change the data model, you change the server code, and then you change the UI code and you change the API docs, but you probably didn't have any anyway. Because of course you look at it, what is this? It doesn't match what I had in my mind because it was built before I had it in my mind. How could it possibly match what I had in my mind? NoSQL development process, and I think I just threw that moniker on there because in this case, like a lot of the times people would justify the need to design the data model first because changing tables in your database, if you have existing data already, can be a problem, right? It can be annoying. It can require a lot of migration work. So I call this the NoSQL development process because this was when it's like, okay, you don't have to do all of the same kinds of migrations anymore. You don't have to do specifically like, I don't know, migrations of the physical schema, but you still might have to like change the data around, right? Nonetheless, maybe you start with implementing the custom server code, maybe you implement some custom UI code, then you stumble upon and maybe even document your API, and then you stumble upon your data model in the process of implementing the internals of that API. So this is better, right? But what happens is after you implement the UI code, you're still like, what the fuck is this? Because you built the server code first. Why are you building the server code first? You don't know what it is that you're building. Until you have all of the UI, building the server code doesn't make any sense, right? But the thing is, people ask for this all the time. Like you'll be starting a project and they'll be like, yeah, you can go ahead and start on the back end and there's no wireframes. And so you're basically just working with this weird fractured set of assumptions in your head to create this thing, this code, this API that doesn't have any UI to go with it. And like, so it's going to always be wrong still, right? It's not as bad as when you were designing the database first. Like maybe you don't have to like rewrite your server code quite as much as you would if you'd had to change the data model, because at least you stumbled upon the data model from your server code, but it's still not perfect. So you could implement custom code for each UI. You implement the fake server code. Like whenever we'd be adding a new form, one of the things that we got to is you'll make a empty action, right, on the back end that just like always sends back a 200. Then you stumble upon your cloud API because then you know what the form needs because you've already built the form. You know what the front end demands, like what it needs to work. And then you also, importantly, the thing that you always forget, you already know what the front end wants to send, but sometimes the front end needs more information back. Like let's say if you're creating a new product in the admin dashboard of something you're building, then you need to know the ID of the new product from the server after you create it so that you can like add it to the list. And that way if someone clicks it, it'll actually work and they'll go to the right page. It won't be that bug that I'm sure all of us have seen before where you click it and then it doesn't go anywhere because it doesn't have the ID of the new product, not until you refresh the page. But instead, if you do the custom code for each UI, you implement fake server code, you stumble upon the cloud API from that based on what you actually need, and then you implement the real server code, and finally you stumble upon your data model in the same way. Like what do I need to store? What do I actually need to store based on what's in the product? That's really all that matters. That's being customer centric and that's being UI first. So now you implement custom code for each UI. You implement fake server code. It's real fast and doesn't matter. And then you're like, what the fuck is this? Because one or more of the UIs changed. And then you just go change the UI code. And then you stumble upon your cloud API. And now you implement your real server code. Now that you've locked down, or at least you're pretty sure, like there still could be changes that cause there to be breaking changes to the API, but at least you've come to like the thing that you're building based on the actual product, like actually on a picture based on what you needed, as opposed to just like you trying to guess before the picture even exists. So if our goal is to minimize technical debt or complexity debt, take your pick, code changes and rewrites, then we need to show stakeholders and our customers the UI as it develops and as early as possible. Because the sooner that they can get their hands on it and the sooner that they can like click around in there, even if it's fake, the sooner it is that they're going to realize that their changes need to be made, right? And then that will save you throwing away weeks of work where where the UI didn't exist yet and everybody was guessing and guessing wrong, because that's what every guess is in that situation pretty much. Not always, but it's going to be mostly wrong. This user first or customer first mentality, it does not end with the UI itself. It doesn't end with wireframes. There's a lot of stuff out there about APIs, HTTP APIs, but we don't design most of the APIs we actually use in our lives. We actually consume them. So designing APIs is like a rare treat. We think that's the theory, right? Anytime we have a form that you submit and we have a backend action to handle it, that's an API. And that's usually what people think of when they hear the word API. They think about an HTTP API, where it involves an HTTP request. But API really can be much broader. And yeah, like Waterline is a perfect example. The .create method in Waterline that lets you create a new record of some model. But we don't design most of the APIs we use. Every time you're typing on a keyboard, that's like an API between you and the keyboard, right? You're using the keyboard API to talk to the computer. Every time we write a function, we're really designing an API. In your app, if you make a helper or if you make a utility, a little utility function, that's an API. Like those functions arguments, that's the things that it accepts as part of the API. It's the interface. And then whatever that function's return value or the things that it can throw, those are its outcomes, and that's part of its API as well. It's anytime you make something that can be talked to. Let's say you have a product where you can upgrade your account. One way to upgrade your account is during sign up, and another way to upgrade your account is after you've already signed up. You can go to the account settings and click upgrade my plan. That code is used in two places, and you might make a helper to handle some of its logic, right? To be able to upgrade. So maybe there's the part that like, make sure you have a Stripe customer, make sure your Stripe's info is up to date, updates the database to say that you're upgraded, and then maybe it charges your credit card. And so maybe you took that logic and you put it in a helper. So that helper, the way that you call it from those two different spots in the code, that's an API. Because what makes it an API is the fact that you're now designing a way that it gets called.
Just pretty much any kind of like communication code.
Yeah, anything that's designed for other code to talk to, because it's an application programming interface. You can think about it. It's like an interface for programmers or for programs specifically. You expose a way for programs to talk to you programmatically. So there's our function, and then this function has 3 arguments, A, B, and C. It takes 3 inputs. It takes 3 things you can pass into it. It names the first one A, the second one B, and the third one C. It doesn't know what they are, right? But whatever the first one you put in there, it thinks that's A. The second one, it thinks it's B. The third one, it thinks it's C. And then there's some behavior on the inside of a function. The API is the blue and bright white and yellow part. That's the interface. That's how you talk to it. The internal of the function, that's the implementation. That's how it's done. And then the function itself and in the interface that it exposes, that would be like the API for that function. So what it returns, that's also part of the API of the function. So like, yeah, technically the fact that the plus signs here are still part of the implementation, but the fact that it returns what it does in the circumstances that it does, that's part of the programming interface. That's part of the API. If you're going to have a function that logs the word hi, and then half the time it throws just a dumb empty error, and then the other time it just returns the sum of A, B, and C, which is what this is, then the fact that it throws that error, that's also part of the API. Arguments are the automobile, and parameters are the parking space. Arguments go into the parking space. Arguments go into the parameters, and automobile goes into the parking space. So these inputs, though, it's a way of kind of not having to say either way. But here we're referring to it as parameters. So the 3 parking spaces, right? A, B, and C, different numbers, different arguments, different automobiles can flow into those. A might be 2 this time, but next time it'll be 5. B might be -3 this time, but next time it might be 0. C might be 5 this time, but next time it might be a giant object. So there's the behavior, there's the inputs, and there's the exits. And the part that's the API is the inputs and the exits. An API usually has some other stuff. So in this case, we might say friendly name, add numbers. We'll write it in the imperative mood. We'll also write a description in 140 characters or less in the imperative mood. We might say add the 3 provided numbers together. We might have a more info URL with an example with more documentation. And then we might even have some containing package that helps us understand how we can import this reusable thing into our project. Like that can kind of be part of the API as well. It's not part of how you call it, but it's part of how you use it. You have to be able to require something before you can call it, right? And then there's the inputs, and we might say what each one is. We might give it a short little noun phrase, like first number, second number, third number. We might indicate whether it's required or not. And then we have our exits. We have our return value, which is a number like 7, and then we have an error, which happens half the time. which is that you got unlucky. Machines are a way of doing that declaratively in JavaScript, but you can also write JavaScript functions. And I think for our purposes here, let's just stick to that to avoid getting too much in the weeds. Let's go around the circle one more time with these things and just level with terminology. Madison, can you tell me why it's important, or one good argument at least as to why it's important to always come up with the user interface first and to work backwards to the code from there?
If you don't come up with something that you're working towards first, you're just gonna be wandering around lost for maybe ever.
Yeah, like what are you building, right? It's like trying to build the inside of a thermostat before you know what the buttons are on the outside.
For like an artist who's getting all these tools for all different kinds of mediums before they even know what type of like art or medium they want to work with in the first place.
Right. Yeah, with the tools thing, that's totally true. And that actually hints at a different problem that people can get in this paralysis where they like pick the framework they're going to use for 2 months.
Oh, yeah.
And then they're out of time. What about designing the data model first? I thought you were supposed to design the data model first. Why wouldn't you design the data model first?
Like it just goes back to the user-centric design. You just want to make sure you know what you're actually going to be designing it for first, but not just the data model conceptually all over the place. It's just not as clear.
Yeah, spot on. Like if I'm going to build a business that does car hop delivery out to your car, because that's hot right now, hot. Like then I could build my own like Sonics, but it's better. And maybe then I'm like, so that would be good if I had that vision. Like I could start the basket weaving for the delivery baskets. But if I just start doing the basket weaving, then what I'm doing is basket weaving. I'm not building that new like Sonics 2.0 where the car hops bring you out like farm fresh food and like beautiful hand-woven baskets. Really, my real passion was to design or to weave the baskets, right? And that's clearly why I'm doing this at that point. And that is with data models too. Like you get really obsessed with like this one tiny implementation detail of where you need to put your shit to build this thing you're trying to create. And if you don't know what you're trying to create, you're just a basket weaver. Aimless, like a wandering spirit. What are wireframes, Rachel?
Just like series of pictures of what the front end interface is going to look like.
What are you following when you make wireframes?
We're looking at it from the perspective of the user.
Right, human behavior. You're following a path of human behavior. Madison, if you saw the word lo-fi wireframes, what would that mean to you?
Wireframes with less detail.
Yep, well said. They're not pixel perfect. Someone like me that was like left in a room with a crayon for a while and a big old volume of paper, and then like you'll have kind of like, or maybe you go into XD and you do some like real quick ones that involve taking screenshots of existing wireframes, pasting them on top of each other, collaging it. If you're just trying to bust out, you're trying to communicate an idea, right? You're not really trying to communicate visual design in the same level of fidelity.
I can't even count the number of times I've started like wireframing something that like we had verbally talked about and stuff, and I'm just like, wait, this doesn't actually make sense. It sounded like it made sense, and like you totally think of how it makes sense on the back end, but then when you start actually like building it out, it's like, wait, this is not how this is going to work actually.
Yeah, which is super critical. It's important, right? Because like if you had started writing that code first, you would have written it all wrong. And also, it's not even that it's just like maybe it's not that you didn't understand. Like usually, it's because the person communicating to you didn't do it right. I said usually. Sometimes it's that they didn't communicate it right. Occasionally, it's that you didn't understand, but most of the time, it's because the person communicating what they wanted to you didn't think through it. Didn't think through what it would fully mean, because the only way to think through it is to wireframe it, right? Making too high fidelity of comps or mockups, we call those, that are a little higher fidelity. That can be a waste of time too. Not for every screen, right? Not unless you have the time, and not unless you're at the size of an organization where that's what makes sense, right? But most of the time you're not. Even at big companies, like on most teams, you don't have that level of fidelity. It's a lot faster to be able to just say like, here's a picture of what we want to head towards. Does that match your understanding? And then everyone agrees. So as long as the wireframes are able to like fully communicate the concept with enough technical meaning to get people on the same page, and enough like, if it's not such chicken scratch that it's like unreadable, then like it's basically achieved its purpose.
It's better to be wrong sooner, because we are bad about throwing out work. If you wrote a backend and like had to change it, you would try and salvage as much as possible. So it still like wouldn't be ideal, because you feel like, but it's hard to say like, nope, this was wrong and I need to just save a copy of it so that I can put my mind at rest, and then I will delete this and rewrite it in a way that makes sense.
You have to fight that feeling of futility that I wasted the last 2 weeks weaving baskets for this car delivery business, and I don't even know what's on my menu.
I realized the baskets aren't actually going to fit at turkey dinners.
Surprise, we're gonna sell turkey dinners because it's hot, 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 but we can't sell the turkey dinners in these baskets, so we're gonna have to throw all those baskets away. And now we're gonna use giant plastic containers. That's what ends up happening. And then you're real sad about your baskets, and you might not even make it to the big plastic containers because you've already wasted your time.
Be careful with going too fast with developing the high fidelity before you communicate it, because then you can end up doing a lot of unnecessary fine details and have to take it out and just wipe the sweat off, like, oops, did those baskets and they were the wrong size.
And I get really obsessed with my menu now.
Yeah.
And I get too obsessed with that, right? Instead of like seeing the big picture. If we can think about the customer journey, if we can think about the user, it'll ground us, because everything that matters is human behavior. And so like if we can think about the human behavior that we want for our customers that come to our basket delivered farm fresh food thing, then we can, that's gonna be a really good model, turns out, to just basically make sure that we're focusing on what actually matters. It's not even just those users, it's our employees. Like, what do our employees need when they deliver these baskets? Is there like weird weight restrictions in the baskets? Are the baskets gonna be too heavy because they have Cornish game hens now, because we were a little bit more practical? Because all that matters is what is the human behavior that we're trying to influence, or the human behavior that we want to enable. Madison, what's Adobe XD?
Tool that we use here to make wireframes.
What's Sketch, John?
Similar to XD, it's just a different company and different program entirely for making wireframes as well.
Right on. Once you make those wireframes, is there anything else you can do with Adobe and XD and Sketch?
Make it easy to like export the images properly.
It's like you could package your materials to deliver.
Sometimes you just need to actually cut out the images from the wireframes, and like, granted, that's more relevant for higher fidelity comps, because if it's a lo-fi comp, if it's a lo-fi wireframe for me, like, it's going to be like in Keynote, Crayon will have gotten involved probably, and there's a lot of copy and pasted screenshots layered on top of each other. So it's kind of like the quickest, dirtiest way to be able to communicate the concept. You don't need to cut out any images from that. But if you got high fidelity comps, then you can go into Sketch or Adobe XD and you can be like, okay, so I'm seeing like 10 pixels of padding here, and I know that this is already measured in CSS pixels, so I can just use that measurement. Or I can see which font exactly is being used. I can kind of get a sense of the border radius even if I want to use for this curved corner.
Like with XD and Sketch, you can go beyond just the visual wireframes and actually create like an interactive prototype.
True that, and InVision. If you're starting a sprint, if you're going into a sprint and there's aspects of the work that are not clear cut, that you don't feel like you could commit to actually delivering, you shouldn't really start the sprint with it. And so if you have something where it's like we're going to wireframe this, figure out what it is, and then we're going to build it, the sprint. That is an impossible situation. How could you possibly do that because you don't know what it is? You can take a guess and be like, yeah, I think I can get that done this sprint. But that defeats the whole purpose of having a sprint in the first place. The sprint exists for the stakeholders to understand when something is going to be delivered, to understand those key dates. It's a way of, now without having to set key dates for features, to be able to say like, okay, I know that it's part of this sprint, and when the sprint finishes, there's a very high chance that this feature will be done. But if you start a sprint and you don't know what the feature is, how can you possibly make that commitment? That's where you want to split it out into kind of two parts. There's the part where it's like figure out what the hell it is, and then there's the part where it's like actually build it maybe later. And there's not even a point in like creating the work about actually building it later yet, because all we know is that it hasn't been wireframed yet. Until it's been wireframed, like maybe sometimes you can take a shortcut. Like maybe sometimes it's like, you know what, it's a verbiage change. Sure, like you can change it. You're still at risk though, because when you go in there and you make that change, and you're at risk even if you had done the wireframe, right? If you resize the screen and the text overflows in a weird way, like maybe you had all of these line breaks in there before that were getting conditionally hidden at different screen widths, right? And now you changed the content and all that stuff broke. So you're gonna have to like redo it, and then maybe you didn't think about that in your original estimation. So some of that's unavoidable. But it's like if we don't even have wireframes, like lo-fi wireframes, and you don't fully understand what you need to be able to estimate the work, then there's no reason to start on that work. And like anyone reasonable should be able to understand why it's not ready to be started on. I mean, I would recommend being kind of a hardliner about that, or at least trying it out, because it's going to make everybody happier and it's for the benefit of the product.
I wonder what a framework or like a game engine would be considered when it comes to developing either the backend or the user-centric front end first.
The game developer would be the user. It really kind of comes down to how are you distributing it? Like whether you're selling it or not, like in some way it gets into people's hands. Whatever you're building, there's people that need to do stuff with it. Let's say you work for Unity and you're working on the Unity engine. The game engine is your product and the users, the customers are the game developers. That's how I would think about it. And similar just like with Waterline. Who are the users of Waterline really? Yeah. Like, ultimately, sure, the users of all the apps, of sales apps, but like directly it's going to be the developers who are working with Waterline every day and using those functions. Especially if you're designing code interfaces, what I've found is always good is like I like to pretend that I'm able to use it already. So I'll write some code that like would work if it worked that way. If I'm making a function called a dance and I can use that function dance in some code, and like I can get it working just like I want, or it'll look like I'll get it looking like I want it, feeling like I want it as a user of the function, and then I'll go and that'll help me understand what arguments the function should take and the return value the function should take. And then I'll work backwards from there to the implementation of the function. Like I don't care what's in your guts. I don't care whether you have an appendix or not. I want to see you dance.
User testing or hallway testing, it's generally better to lean towards the higher fidelity side and just kind of match the user experience as much as you can. I've also seen like tests where they use the lo-fi version and they just like give us ideas basically. That just doesn't always seem to go as well. You might not get much feedback on those.
You're right. If you're going to show something for the purpose of a usability test, like to get some feedback, it might be good to pick some of the most like solid parts. Yeah. Or go to someone who has enough experience to have the breathing room for imagination when they look at your plan. If you have a stakeholder and you're showing them wireframes or high fidelity comps, and this is especially risky with high fidelity comps, there's a large percentage of the population of Earth that doesn't understand the difference between a picture of something and it actually working and being interactive. And I wish I could say that this is like, it might be getting better. I'm sure it must be. And I'd like to say that I'd only seen it, once or twice, but I've seen it in probably more than half of the projects I've worked on. Watch out for that. It's really important, especially this is true with InVision and other interactive prototyping tools. If you're going to show them something that's a clickable prototype, it can be really easy for people to think that it's done. And no code has been written yet whatsoever.
Take this thing that's already pretty much working and you put it in the code, right?
It comes from a fundamental misunderstanding of just how to build it, And similarly, if you were to build some HTML and CSS and you had all of that ready, and again, the cleaner and nicer it looks, the bigger the risk is because it feels like it might be done, even if you haven't begun the JavaScript. So I really like doing HTML and CSS first. I think it's the right way to build something internally. But it is risky to demo something that's HTML and CSS only to someone because it's even in the browser. Like it's even more believable. And even a front-end only prototype, let's say you made the whole thing interactive and you had all the page script was done, all the events were there, and like the modals would come up. But after and it would even be fake loading spinners. Like let's say you went that far and you had you had the error messages in there, which again is something that we regularly do internally, right? When we're building new features. Still, even then, it's risky to demo it to someone that doesn't have that depth of experience or understanding of how to write code, or at least how products get built, because that person could easily think that it's done, but nothing saves. And then once they get that wrong expectations, just like a lot of things in our life, having the wrong expectation can lead to conflicts. I'll leave us with that warning about wireframing. Careful who you show something to before it's actually done, if they're one of your stakeholders, lest they get the wrong idea and then get really disappointed later or get the wrong expectations about how long it takes to build something. I think that's all I got. Thanks, guys. I'll see you next time.